Hello, my name is Mia Whithoff, and this is my Physics 2212 Lab 3. So, for the introduction, the purpose of this lab is to determine the distance dependence of a magnetic field of a bar magnet. The physical principles used in this lab are the Biot-Savart law, which is B is equal to mu naught over 4 pi times 1 over r cubed times 3 times u dot r times r minus u. So here are the models used in this lab. On the left, you can see the experimental model of how we collected our data and the coding model of the electric field of the bar magnet after the data was collected. So for the experiment, we set it up by crossing two meter sticks perpendicularly to create a coordinate axis of sorts. And then at the end of one of the meter sticks, we put a bar magnet. And then in the middle of the meter sticks, we used our phones, and we had an app on it that was that it was acting as a magnetometer and was measuring the magnetic field. So throughout the experiment, we varied the position of the magnetometer on the meter sticks, and we're able to get different measurements from different places along the axes that we created. The system of this lab is the bar magnet, and the surroundings are everything else in the area. So for the coding portion of this lab, we're creating the code for the magnetic field to compute the magnetic field of the bar magnet. So we first established the magnet at the origin and wrote a function to create the magnetic field seen on the left side. And then we started with the arrows to show the magnetic field, drawing two of them that were on axis, and then we drew four that were perpendicular to the axis, and then also drew an arrow that was at a 45-degree angle from the axis of the bar magnet. So the results of this lab, here you can see the experimental measurements. These data points are slightly off. It's supposed to be decreasing linear. This graph is taking the natural log of the magnetic field and putting it against the natural log of the distance. And this is helping us get the determine the distance of the showing our data from measured from the magnetometer and our distances that were collected. So the results of the model, the computer model, were that the B field perpendicular like 0.3 and 4 was negative 6.3 times 10 to the negative 3 in the negative x direction, and the distance found was 0.281, and that is in meters. You can also see the magnetic field at the 45-degree angle there as well. Some errors in the lab were likely due to inconsistencies in the magnetometer, as it being in our phones and we not knowing exactly where it was measured from, and this also leading to inaccuracies in the distance measurements because the phone is quite large. It is hard to tell exactly where the magnetometer is reading from. So what if you hadn't oriented your experiment to compensate for the magnetic north and had instead laid out your meter stick at some intermediate angle with respect to the Earth's magnetic field? How would your results have changed? So if we weren't if we weren't pointing like our meter sticks in the direction of magnetic north, the component of the Earth's magnetic field at that point would not have been zero. So we would have been affecting our results of the magnetic field of the magnet. And why were if you were to stick two identical magnets together end to end and run the experiment again, how would you expect the measurements to differ? The direction of the magnetic field would stay the same because the north and south poles would still remain in the same location, but the magnitude would increase because um, there is really more magnets there. And that is my lab. Thank you.